Okay, here we go with this lesson. So I'm going to give you a quick tutorial on how to use this program. And then any other questions you may have, you can obviously contact me privately and ask me how to do this, and we'll work with it. So first thing I want to do is I just want to point out all the things that are available to you on this. So if you look on the left-hand side here, you have a wire, okay? You have a battery, a light bulb, which is really nothing more than a fancy resistor. You have a resistor. You have a switch. Now, for our purposes, for this particular lab I'm setting up, you don't need to look at anything else, but if you look, they did give you some other things. They gave you a fuse, a battery, I don't know what the difference in that battery is. Then they give you a whole bunch of other things that you could technically put in a circuit if you wanted to. Obviously, some of them, like the dollar bill and the eraser and things like that, are meant to kind of be funny, but really to show you that, you know, those are non-metals, so those are going to be really high resistance things. But we don't worry about those. We're worried about these first five things, forgive me. Now, over on the right-hand side, it says show current. It says electrons and then conventional current. We're going to stick with electrons. We're going to leave labels. We have voltmeters if we need them. We have an ammeter when we need it. So we'll get to that in a minute. Now, these, we're not going to touch these because we want the wire resistivity to be really, really small. We want to basically be able to ignore the resistance of the wire, okay? And here, the battery resistance, we also want that to be relatively low. So we're going to shrink those down. Now, one thing I do want to point out is we could, if we really wanted to, touch that button. If we touch that button, if you look over here, now these things are the schematic drawings that we've been working with all along. So if you're more comfortable with this, then by all means do that. If you want to work with it in more of a pictorial form, also by all means do so. Okay? So here's what I'm going to first do. I'm going to show you how to set up a basic series circuit. All of these devices over here are touch and drag. So I take that battery, I drag it over here. Now I'm going to take a piece of wire, could drag it here, take another one, drag it here. Okay, now I'm going to attach a resistor. So what I'm going to do is I'm going to just show you how to make a really simple series circuit. Okay, take another piece of wire, attach it here. Take another resistor, place it here. Another piece of wire, place it here. Another piece of wire, place it here. And mostly because I'm anal retentive, I'm going to do that. Now, the second you connect this thing properly, what you see happening is you start seeing the flow of these electrons, right? So you actually kind of get the picture of what I was explaining in class, where it's like a single road or a single way highway where the electrons can't jump over each other, so they have to go this way. Now, once you have this set up, you can start adjusting things. So if I come over here and I click on that, if I click on the resistor, I can increase the resistance. If I increase the resistance, you notice very quickly that the electrons slow down to almost a complete stop. Reason being, if I have more resistance, according to V equals IR, if I have the same V in the battery, right, the bigger my R, the smaller my I. V equals IR. Now, we're going to set this back to 10. Okay. Now, what you could also do, it's not letting me do it with this. Okay, so you set this to very sensitive, 10. Okay, that one's also set to 10. Now, if I decrease the resistance, same, the opposite idea happens. If I decrease the resistance of this guy, well, the electrons start moving faster because there's less stopping the current from coming out. Now, I can get them to flow even faster if I increase the voltage. If you go too fast, no, maybe not. If I go too low here, it starts telling you this would be a problem, right? Things start going on fire. So, this is just kind of interesting because you can arrange, you can change the resistance on each one of these, you can change the voltage on this guy. So, in the lab I sent out, you're going to notice that I asked for a specific voltage, a specific resistance, a specific resistance. Now, just as a reminder, this is kind of the pictures we've been drawing and the pictures you've been seeing, all right? So here we have a resistor, and a battery. Okay, everybody with me? All right. Now, I also ask you at some point to figure out the voltage. So, if you look here, we already know the voltage of this. Let's set it to an easier number. Let's call it exactly that. Come on. Let's call it 50. Right now, if I take the voltmeter and I hook it up here, boop. If I hook it up here, it stands to reason it's going to read 50 volts, right? Because the voltage across my battery should be 50 volts. Now, if I bring it up here instead, on either side of this guy, now, what's weird is it's reading negative 27 volts, and we're not really going to get into why that's the case. If you want to rearrange it, you could do it that way, and it says 27.4. So, that would be reading the voltage dropped across just this device. So, from this side to that side, okay? If I want to check the next one down, it would be this. And that comes out to be 22.6. So, 22.6 and 27.4 adds up to 50. Okay? Now, let's bring this guy back. Now, the ammeter. There's two different ways of doing this. You can use this particular ammeter. So what this particular ammeter does is it gives you like a crosshairs, like you would have in like a rifle or something. And you can leave the current thing here, and then you could just place it anywhere on the wire, and it's going to tell you what the current is. So here it's 1.37. Up here it's 1.37. Up here it's 1.37 because this is a series circuit. So basically anywhere you go, it's going to read the same exact current. Now if you wanted to, you could have placed one of them. You could have placed the ammeter like this. You could have... It's not letting me do it. Alright, well, forget it. I'll bring this guy back. Go away. Well, we're just going to leave them there for now anyway. Okay, so now I've reset the whole thing. So that's the basics of how to build this. If I wanted to build a parallel circuit, let's just really quick talk about that. I'm going to take battery, wire, 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 wire. Alright, now I'm going to take a resistor, I'm going to put it here. Now, right now I've just built a series circuit, but remember, if I want to make a parallel circuit, I have to have the ability for the electrons to go somewhere else as well. So, what do I have to do? I have to basically make a separate path for this guy. And boom. As soon as I do this, now all the electrons are flowing. Now, here's what's cool, because we can use this to prove some of the things we talked about in class. Here's my voltmeter. I'm going to come over here. I'm going to check the voltage across the battery. And right now it's set for 9 volts. So, if this is set up truly as a parallel circuit, we should be able to check the voltage across this guy. Boop. And that should be 9 volts as well. Come up here. And that is also 9 volts. So, the voltmeter works pretty well. Now, the ammeter. So we take the ammeter, let's place him here. And I'm going to find the current here. Now, this is the current coming directly out of the battery. And it's going to be 1.8 anywhere along here, right? Because that is before the split happens, which is over here, okay? Now, also, anywhere over here, because this is after those two currents got back together. So I'm going to come over here, 1.8, 1.8, 1.8, and boop, all of a sudden it's 0.9. Now, if I bring it over here, oh, also 0.9. Now, why is that? Because it gets here, right, at 1.8, right before it gets there, and this guy has a resistance of 10 ohms, and this guy has a resistance of 10 ohms. So, because those have the same resistance, if you did V equals IR, you would get a calculation that showed the same current through both this one and this one, all right? So if that's the case, and you have 1.8 beforehand, each of them is going to get a split of the 0.9. Now, if I increase one of these resistors, so let's say I make this guy 20. Well, you can already see, this is the kind of cool thing about this also, is you could see the slowdown of the electrons in the leg that's highlighted. And if you look, the current in there is much smaller. It's 0.45 now. Now, this is now 0.9. So this is getting twice as much current as this leg. And you also see that the total current has gone down significantly. Why has the total current gone down? Well, because this leg isn't allowing current to flow through it as quickly. So even though this leg, even though this leg has the same current flow as it did before, also very important, which we're going to talk about later in the week, this one has less current flow through it. So this is basically it. This is the tutorial on how to set up both a series circuit and a parallel circuit. So I have put an assignment on the Google page for you, and I want you to go to this program. I left the link on there so you can get directly to this page. I want you to set up these circuits that I made mention of in the assignment, and I want you to write down answers to all the questions, or type out answers to all the questions. I left you more directions on how to do the assignment and how to give me the assignment once you're done with it on the page. All right, so hopefully that is understandable. If you have any questions, by all means, let me know. All right, I will talk to you guys soon. All right.